Welcome to our physics practical lesson, physics practical experiment number 9. You see that the series of our experiment. From the first series, we have started the explanation of source of errors and their precautions within our current experiment or current electricity experiments. And we started the experiment number 1, and now we are in experiment number 9. So you are welcome to our channel. Subscribe our channel, allow notification. When we upload a new video, a new lesson, you'll be notified with a notification. And at the end of this lesson, comment, give us a feedback. You can ask the question for the physics experiment, for the chemistry, even in biology practicals or other science subjects, and you can be answered through here Skills Learning Network. Okay, we proceed with the experiment number 9. This experiment performed or was examination question for the national examination in 2015 physics practical 2B. That is our experiment. We are going to see how have been asked, how have been solved, to see derivation of the questions, how to plot the nature of the graph, and to see the nature of a graph. And at the end, we will see how we can solve those questions found within this experiment. So you are welcome. We are going to use experimental circuit. You are going to determine, and the aim of experiment, you are required to determine the internal resistance of a cell provided. And our experimental circuit looks like this one. We have voltage. Voltmeter is parallel with a cell. We have a switch, and this is resistivity wire. We have constant wire. So there is a different length. We are going to vary the length of our wire. Then we record the value of potential difference across this circuit. That is our circuit. The procedure of performing this equation you'll see here. Procedure A: connect the circuit as shown in that figure you see. Procedure B: adjust the distance of L, length of wire, to be 20 cm. Number 3: close the switch K. Number 4: read and record the readings of the voltmeter. It means after connecting the 20 cm of the length, you have to close the switch and you read the value of voltmeter, and then you record. Then you repeat for the procedure B up to D by changing the length of the constant wire to be 30, 40, 50, and 60. And then at the same time you change the length and you record the value of voltmeter to get those corresponding data, V and L, which is the length. Then after that, tabulate your results, including 1 over V and 1 over R, 1 over L. It means you will have a different column. The first column is V, the second is length, the third is 1 over V, and the fourth column will be 1 over L. And after that procedure, recording the results, you have to perform these questions. For the step G, that is those are questions you have to answer clearly. The first, or the proceeding with the plotted graph of 1 over V against, this is against 1 over L. That is our graph. Then find the slope of the graph. Number I: read the intercept of 1 over V axis. Then calculate the value of the reciprocal of intercept. You have to calculate the reciprocal. It means 1 over V, which is the intercept. It means will be 1 over value you have ready from the graph. And then what does the value of reciprocal of intercept physically represent? What is the physical meaning of that reciprocal of y or 1 over v intercept across 1 over v axis? And then calculate the internal resistance of the cell through this relation. You can use it because you have slope, and you can put it to get the value of internal resistance. Then list down 2 possible sources of errors and 2 precautions to be taken into account. So you are required to mention source of errors, which is 2, and their precautions to be taken. For the first video about our lessons was the source of errors. So you can search within Skills Learning Network to see the source of errors in current and their precautions. Then after looking this procedure and some questions, let me proceed with the theory of our experiment. This is very important. You have to know before plotting the graph where your graph is going to pass through. Is it y positive axis? Is it negative y positive y axis? Or how is going to pass through? You have to use theoretically the theory of the experiment in order to know the nature of a graph. Let's proceed with the theory of experiment. According to our circuit, you see there we have V, voltmeter, we have internal resistance, we have resistance of a wire. So our general equation will be EMF is equal to current passing through that circuit, resistance of wire plus resistance of internal resistance. But current is equal to this one, E is equal to R plus over R plus R. But current is equal to V over R. Then instead of using I, we use V over R. Then V over R is equal to EMF over R plus internal resistance. Then in order to get 1 over V, we have to reciprocate the equation, this one. So it will be R over V is equal to R over EMF plus R over EMF. In order to get 1 over V, we have to divide R both sides. Then our equation will be 1 over V is equal to bracket R is equal to R over EMF times, it means when we divide this one, will be times 1 over R plus R over EMF times 1 over R. So our equation will be 1 over V is equal to 1 over EMF, because R and the R have been cancelled, so it remain 1 over EMF plus R over E times 1 over R. But R, you have to get, in order to get the length 1 over L, we have to apply resistivity concept. So from resistance is equal to resistivity times length over area of cross section, or cross section area of wire. So 1 over V is equal to 1 over EMF plus R over E times 1 over resistivity times L times length over cross section area. Then this one will be multiplied, so it will be 1 over V is equal to 1 over E plus R over EMF times area over resistivity times length. It means 1 over V is equal to R. In order to get 1 over L as x-axis, we have to change the position. It means this to be this side and this one to be another side. I think you see that is our equation. So generally, when you multiply this one, in order to get 1 over L, we have to put this one together. It means 1 over V is equal to R times area over EMF times resistivity bracket 1 over L plus 1 over E, and that is our general equation for our experiment, which obey the nature of our graph. You have to derive before connecting your point in order to get the best line, to get the nature of a graph, and to get the correct value of slope at the end, to get the total max of the graph, which is the best. So y is equal to mx plus c. So 1 over v is equal to y-axis, slope is equal to r times area over EMF times resistivity. But the x-axis is equal to 1 over L plus 1 over EMF, which is the y-intercept. So the nature of the graph looks like, so your graph is passing through y positive axis. So how to get you have seen that y-axis is equal to 1 over v, so x-axis is equal to 1 over L, m is equal to this one, m is equal to this one. That is the value of slope. So internal resistance obtained from that value of slope. So generally, when you have a data, it means internal resistance is equal to unity in ohms. To get the value of EMF obtained from y-intercept, when you see that is our graph. So EMF is equal to reciprocal of y-intercept, and our question physically represent y reciprocal of y-intercept is equal to electromotive force or EMF of the battery or of the cell. That is our experiment number 9, and the experiment performed in NECTA examination 20 and 15 practical for Form 4 students. I think now we end up here for experiment number 9. For the coming lesson, we will see experiment number 10, and then be ready for the coming lesson. Give us a comment, subscribe our channel, share this knowledge, and like it this lesson. For the coming lesson, experiment number 10 will teach you, will bring it to you here, will let you hear for the experiment performed for the same year, but the experiment of 2C are the physics practical 20 and 15 physics practical 2C NECTA examination. So you are welcome. You are so welcome for this channel. Within this channel, I think you have understand. Thank you for learning with me.